One, two, three. Okay. Today I'm gonna make a recap about the pojo class, enum class, singleton class, and immutable class in Java. And first, I'm gonna come up with the pojo class. And by definition, the pojo class with this keyword, the pojo keywords, would stand for plain old Java object. And there are some features with the pojo class that is not depend on any framework. As you know, there are some provided framework with the Java, including Hibernate, Spring Boot, kind of thing. And the pojo class is something that will not depend on this framework. I'm gonna let you guys see the example, the class that depend on this framework. And we call it as the concrete class. And you see here, this class that using some annotations from the Spring Boot framework. That is the entity annotation and table annotation, which will create a table automatically for this class. So Spring Boot is gonna control these classes for us. So they call it as the concrete class. And the pojo class contains various fields with polygetter and setter. As you see here, this is the simple classes with some attribute and the constructor and the getter right here. And might contain some business logic but remain independent. As you see here, for this class, we define the separate birthday class. This increment the age by 1, and it's a independent method. And another feature of pojo is that it can use any Java applications with modifications. Then I'm gonna come up with the enum class, and by the definition, in enum source for enumerations in Java a special data type that allow to define a set of named constant. And the keyword constant in Java, which means that like this variable are not changes, not allow, modify. And this only created one time through one time through our programming. So this keyword, we can achieve the constant variable in Java by declaring this variable as the constant, a static final, right? This keyword is equal with the constant because static variable in Java, which means that the variable belong to the class. So that's we create one time create through project because it's not belong to the class, not belong to the object. And for the keyword final, which means that we cannot modify it. So if we want to create a constant in Java, we have to use these two keywords, but the enum provides us the way that we don't need to write down the two keywords. So it provides more readability for all syntax. As you see here, that we create the enum class, in which we place the class keyword by the enum, and inside we define like 3 variable. That's the constant value, right? Otherwise, if we not use the enum, by we have to create the constant variable by this way. Like for example, I create a class enum name, right? It is similar with this one, but I gonna create the constant 1, constant 2, constant 3. I have to do it like this way: static final string. The data type of this one is the string, constant one, and its name is like hi. As you see, You see, it's like write a lot of things, but the enum allow us to write the more short than that. And here this is example of the enum that I create the physics array of the day in the week, and then this is how I use it inside the main, in which I create the object of the enum of the day enum, and then I access the variable. I insert the variable by this way, and because it's static, so we don't need to display the new keyword like the normal class, because this is a constant, and in Java the constant is like is stored inside the heap, specifically inside the heap. This reason store two things. First is the metadata, and the second is like the constant variable. And first I gonna explain what is the metadata. The metadata is the reflection. Right, when we use a reflection, the information is gonna store it inside this way, and reflection is something that allows us to access and use the objects at the running time, and Spring Boot framework using this mechanism to manage our object. And then another is the constant. Right, the constant is the enum, and these objects created one time and allocated here. So even that if we not use all of them, but all of the variable inside the enum, but all of them already initialized inside this memory. So it's already there, and we just basically access it like this way. And this is the example that it uses inside the switch statement, in which we are displays the variable of the enum, and then for the statement of the switch case we just pass it inside, and for the each case we pass the enum value like Monday, Wednesday, day, right? And if it's missed, if it matches, it's gonna print out the message. So I'm gonna test example inside the code. Right, you see here, this is like my enum. My enum I display it like this way, and inside the main I use the switch case, right? From expectation, it's gonna print this message. That is a Wednesday. It's work like this way, and there's some advanced feature with the enum field constructor and method, which say that inside the enum we can insert some fields with the enum itself, as with the constructor and methods, just like the classes. I just see here the example that associates the string with the enum field, right? And we declare this like this because we have to put this keyword at the final, because we cannot modify it. And we call the constructor for this, so that each string is gonna search into this field, this enum field, and the method that's gonna return the message of the strings field of the enum. So I'm gonna take example for this. For example, and we can push anything, create any field. For example, I just want to create like the string and one number for just be example 1, 2, 3. For example, for the Monday, I'm gonna put the number of 2, and then that. I gonna use like I'm gonna push all the string AI already suggested for me, so it must be faster. First I just pass the string as a number and not modified yet. Right, we need to modify for the e fields that match with the e term. Right, for this about today, I'm gonna visit the today and with the number of 2, 3, and Wednesday 4, 5, 6, 7, 8. Thursday, Friday, Saturday, and Sunday. You see here that right now it's informing me an error because to associate the strings and the number to the enum value, we have to have the constructor and the field to storage. Right now it's create the field of the string, which means this associated with a of them, and another is the value, right? And to insert into them, I have to have the constructor that's gonna accept the string and the values and assert assert the field and the value inside of them. This one, right? And I just want to create a matrix that print out the string of enum, right? So it's gonna return the description of the string and the number. I just want to create another number that's gonna the value of the enum, right? And another one that's gonna print both of them. I forgot to put it to final, so that it cannot be modified. Two strings, right? It's gonna format this for me as this way, and then inside the main, I gonna print out I gonna score this method. For example, today dot. As you see here, this are two methods. I just define it. I just want to use the string that's gonna print out information for me. For example, because it's a Wednesday, so it's gonna print me something like it's informing an error. Why there's some an error right here? Let's see, there's some an error here because this one return the string. So that we have to like using some prints out. Okay, let's go. If this have worked right, it prints like this way. It's gonna print the message of an enum and the value that associated with it. And we can define a multiple, a lot of field as long as we want, right? And necessary. For example, I can define another string, and like I have to provide the field, declare the field, and put it inside the constructor, right? This is about the field construct and methods, and then we come up with the abstract method. Abstract method is something that force for us to provide the implementation for each of an enum, right? For example, the enum, thus we provide the abstract method apply, and then each of the enum value have to override the methods for them. So for this example, I'm gonna create some methods that abstract create the abstract methods that for example I just increment the or it's already the final so we cannot change it. Let's see with print the message again, right? I just want to print the string description with the another string. Right, first I declare the public with the modifier abstract void print description. And then as you see here there's some error appear because it requires to implement for override. We need to override the method. Right, we're gonna print the provided the private the provided message and this string view of this. This is all the things that I want. Right, we put the keywords override. Okay, this I override the methods for each of them, and I just provide like prints out. And because I override methods so that I can have the user the custom implementations for each of them, right? For example, right now for the Monday, I'm gonna print something that like system out. I'm gonna print like something. This is not a weekend, right? This is not the weekend. It's Monday. So what hot? And for the Sunday because it's the this is the weekend. So relax. Right, I can have the custom implementation for the enum value, right? For this one, I just provide small one, and each of them override, so it can have its own implementation. This is all point of the abstract methods. That's when we want to have like the own implementation for each of them. And we can implement the interface also. For example, I always create the interface right here to implement the interface. We put the keyword implement, and this interface is that interface because it's inside the same package, so we don't need to import the interface because you see here that it's gonna appear an error because we provide the interface, so each of them have to provide implementation for this method. Right, it's for us to override it. if I gonna provide some implementations right here, if this value less than 7, oh, I think, oh, the name is right. Oh, because I said it is after private, so no one's gonna set it, right? To access this, and I think that I have to define another getter, so I just define the getter right here. Oh, it's already there, I forgot it, so I just call this method. If the get value is less than 7, I'm gonna say that it's Monday, so work hard, right? This is its own invitation. For this one, this is not the weekend, it's the Wednesday, a Tuesday. And you see here the implementation is repeated, right? This one, but I just want to show the point. That's why we use the abstract method, the interface, to treat the abstractions. I just print this out, copy its part. I just want to check if it's weekend for this interface, for example. So this is the Wednesday. This one is Thursday. Thursday, and it's a Saturday, Sunday. Okay, it have its own even when it's even L I sprint. Well, anyway, this is got a stupid example, but anyway, I just use it like this. And then, for example, for this one, I call the method like today dot print description. Print description. This is like abstract method, and the test method. Okay, it's gonna run now. Let's see. This description. This is the Wednesday. Alright, this is the provided message, and this is its own strings of the enum. And another is abstract method is gonna check the logic that if it's not a weekend and it's a Wednesday, so what hard. Right, the implementation for the methods of the interface for this value inside the enum. Even the example is not intuitive, but I just use this. And there is some parent message for enum that including the values that's gonna return or the arrays of the value inside the enum. As you see here, that's for each value inside the enum, right? All of them is like an array, So if you want to see all of them, I can use like this method, right? For example, day right here, I display an array, and then I call the value method. So it's gonna return an array for me, and then I'm gonna use the for loop that's gonna print out all of them. Let's see. It's gonna print out for me the day, because I already declared like the toString methods. So this method gonna print out. For example, I just use another name. So it should print the actual object, right? It should print out the actual value of the array of enum. But because the toStrings is like why when we use the toStrings method, it's gonna print out it because every class in Java is the subclass of the um, object class in Java, and this object already have some built-in classes, including toStrings. So when we use the toStrings, it's always override for us. So in the main, if we just print it out like this, it's gonna print out this toString method. So it's very up to us to using toString. But right now, I just want to see the actual value of the enum array. So I'm gonna write down another name for this one. So it's gonna print out the actual value of the enum. Right, and another method, let's say, is the value of it's gonna convert the string into the enum value. For example, right, for this way, I declare the today by using access like this way, access by the started field, but I can access it by the string. For example, I ask the user to provide me the string, right, and then I use the switch case to check the provided string provided by the user is the Monday or not, right? I gonna display like this way. Right, it's gonna check. Alright, it's a Monday. It's gonna print out is like this way. And then it's the name. It's gonna convert. It's gonna return the name of enum constant as a string. For example, we want to get the value of the enum and return as a string. So we can manipulate in some way. We can use this method, right? We first declare a string and return a string, and then we convert today to this method in name, right? Name, and then we print this out to check it. It's gonna print the string as a string. You hear this? It's gonna print the Monday as a string. And ordinary, this gonna return the positions of the enum. And another feature inside enum meta, for each of the value that we put inside the enum is gonna associate with the index that's ranges from 0, right? It's for example, for this Monday, this is indexing with the 0, 1. For today, it's a 1, 2, 3, 4, 5, and it's automatically do by the enum. So for example, right now I use like ordinary feature today dot ordinate, right, because I want to know like the positions of this enum value inside. For my expectation, it's gonna be 0, right? As you see here, this is a 0. And this is all thing about enum, and this is the example with an enum. Thus we declare like two fields for the value inside the enum, and then we declare the field and the constructors to initialize the field for the value, the enum value, and then we use the methods that gonna do some logic here. Right, it use some few of the value and modify with the mask right here, and then it's gonna come up with the concept Java singleton class, and from definition, a singleton is a design pattern that ensure class had only one instance and provide a global point to access that instance. And from this definition, we're gonna appear the question. That's why we use like the singleton class. Let's take example like this. I have the database class, right? It's gonna and the method so that I on upload the database from the database like PostgreSQL kind of thing into my class so that I can use it. And I have like some another class like database connection, right? In which I gonna create the instance of this database, and throughout my program I just want to use one time because there's no point I have to create multiple database, right? I just create one so that it's gonna be consistent with my whole program. And to do it, we create the singleton class. At first, we're gonna come up with there are several ways to implement singleton in Java, and first we're gonna come up with some the eager initialization. So first, for this way, we declare and for the singleton class, we declare where the start is final, and as I mentioned earlier, the start is final. It means that the constant, so we cannot change it or modify it anyway, and we can access it outside the class. You see here. Just we create instance for this one, and here to with eager initialization because its own way initializes, even that we not score it, and we provide a private constructor, which means that we cannot construct this class multiple times, and it just automatically do it for us. And here is the way that we access um, the object that we use the setter right here, the getter right here, and it is simple and thread safe, but because this instance is great even if it's not used, which means that like when you just run the programming, no matter we use it or not, it's always created inside, as I say, it's inside the heap. Right, for the constant, it's gonna store it in here. Inside another specific reason, it's gonna store the static final, which means a constant variable. So it's not necessary to create it if we not use, right? So we come up with the lazy initialization approach in which we can control the lifetime of our object. So similarly, we declare the private static, but not the final, because to create the objects, we have to call the method, right? In which it's gonna initialize for our object. So if we put the final right here, we cannot call the method because we change it, right? We initialize, we change from null to another one, so it's not allowed. So we not use the final keyword right here. And to create the object, we're first gonna check whether the object is null or not. If it's not null, we're gonna create another one, and then we return the constant. So it's gonna use it only when we want it. But there are some problem come with is in our thread safety, because multiple threads can create multiple instance. So what it means is, for example, I have a two threads, right? Thread 1 and thread 2, and it's called the method, the get instant method, right? When I call the thread 1, it's gonna create this, right? It's gonna create this, and for example, if it's gonna create get instant, right? And then because is the null, it's gonna scrape 1 for this, and for the thread 2 it's still the same, right? So that is gonna scrape 2 times, even we just one query is 1 time, right? So thus we come up with the 3 thread lazy initialization, in which we use the synchronized keyword, and the synchronized keyword, which means that we the only one thread can access 1 time, because it uses some the lock and unlock mechanism, which means that, for example, for the thread 1, when it access the method, right, it's gonna lock this method, so if the thread 2 come to this method, because it's already locked, so it cannot access it, so inside the lock, the class gonna create the value, create the instance for the class, right, and change to null, so that it's gonna unlock. When it's unlocked, as long when the rest 1 unlock this method, the rest 2 can access it, and when it's accessed, because it's already null, so that it's not created a class anytime more, this, and just return the object. And there are some problem with the approach, is that like can cause performance issues, which means that like because one thread can access 1 time, so which means that every time we access the object, the synchronized keywords always calls, even that it don't need it, right? Which is gonna cause a problem issue. Like imagine, right, when we always create the object, every thread gonna go through to check this object exists or not. So it's always you, the synchronized keywords always there, and it's always judges. So we don't want to use the synchronized keyword and just use it as long as we want, if it's necessary. So we come up with the double just login method, in which we still create another Sandwich method, but the only difference here is that we use the volatile keyword. I'm gonna explain this later, but let's see the mechanism itself. So first, it's gonna come up to the class, and then it's gonna check if the object is null or not. If it's null, it's gonna lock, right? It's gonna lock this one. It's gonna lock this one. So just one thread can set it, and then it's gonna check again if it's null. And so why we have to check it 2 times? Because for example, right, if we and the reason why I need to check 2 times is that, let's take example, right, that we for example the press ones go into this, and then it's gonna check the instance is null or not. If it null, it's gonna come into the lock, right, and then it's gonna check again. If it's null, it's gonna create the instance for this one, right? For example, if the thread 2, I have another thread, thread 2, and then when the thread 1 get inside the lock block, this lock block, and then it's gonna check for example class, when the I'm gonna test it again, maybe I lose the track. For example, I have the 2 threads, thread A and thread B, right? For example, it's go at the same time, and for example, when the thread A and B come into this get instant method, it's gonna judge first if instant is null, right? Both of them gonna go inside, and it's gonna check if both of them is the null. But for the A, it's gonna go first, or B in some words. But for this example, I just assume that A gonna go into the lock first, and so that the thread B have to wait the A, and then when the A come into the method, come into the lock block, it's gonna check again. If it's still null, it's gonna create the instance for it. And the reason why it have to like 2 check-in is that, for example, when the class A already is there, and then it's gonna create the object, and then it exists the lock, and it's gonna be unlocked for this one. And when it's unlocked, the thread B gonna come into, and it's gonna check come into the lock, and it's gonna check again because right now it's not new anytime more. So just return and don't need to create another one. And for example, for the thread C, right, when because we already create the instance, so because for thread 3 C is come later, right, when A and B already exist the lock, and then for C it just come into the get instance, and it's gonna check, and it see that for the first check-in, it already see that the instance is not null, so it just return the instance, right? And this mechanism is used by the volatile because as you know, for the CPU it have the multiple core, right? For example, the core, I have a 2 core right here, and the core, this first core it work with the thread A, and this second core with the thread B, and for the each core it's gonna working with the cache rather than the caching rather than the main memory, right? Because it's gonna work with the caching first before return the information into the main memory. I'm gonna call this one in main memory. Okay. And without the keyword volatile, this gonna be a different scenario because, for example, when the thread A come into the core and it's come to the cache, and this cache gonna check inside the memory whether the instance is null or not. Right now, it's in null, right? It's gonna null because this one is null, so that it's gonna inside the caching, it's gonna create the instance, right? So call the new instance for this inside the caching, but it not returns back to the main memory yet. Right now it's not return the information into the memory yet. So for the core B, for the thread B, when it comes out the caching and it's come inside the memories, right now it's still a null. It's still a null, so it's at the caching it's create another one for the instant, right? So it's create a multiple instant. So the volatile keyword gonna help us to solve this kind of problem, so that rather working with the caching, it's gonna work directly with the main memory, which means that for the E core, right, this core A, core the rest A and the rest B gonna come with this 2 core, and it's gonna work directly with the main memory. Alright, this is the way of using the volatile keyword. For example, for the rest A, when it's come to the main, it see that it is a null for the instance, so it's gonna create a new instance, right? Create a new instance, and then it's when the rest A exists, the lock, the rest B gonna come up to the main, and right now it's gonna check, and it see that the instance already exists, so it's gonna return, not create another one. And the reasons why the caching not return the memory into the main that immediately is that the mechanism of the caching is that it's gonna return the memory as not necessary, which means that's when the caching is full and it needs the room for the new information. It's gonna return back the information to write into the main, otherwise it's just keep there. So we have no guarantee that the information inside the caching will return to the memory immediately. For example, when I create the instance inside the core A, the core that working with the thread A, right? When we create the instance right here, it still have a lot of room right here, so it's not gonna flush the information inside the cache, but just keep there and it's waiting. So the thread B don't know the information inside the main, so it's gonna create another one. So the I think volatile keyword help us to solve this kind of problem. And another solutions with the singleton is a pure pool started in the class, and using this by apply like a netlist in the class. And for example, for we create a private constructor so that we cannot access this, and then inside um, we have the get instance that we gonna call the inner matrix, the inner the inner class, and the inner class, there is some behavior of the inner class is that the inner class only created once we create it, otherwise it's never only it's referred it's gonna create it, otherwise it's stay there and not created, right? So here when we create it's gonna create instant for us, right, to sign this final one. This is the status inner class, and the pro is to let's say lazy initialization, no single line overhead, and slice more com complex. And another is the Java immutable class. The immutable class, which means that we cannot modify after they are created, and I inherit this, let's say, and can share freely without need of synchronizations. And key feature of the immutable class is that it have to have the final keyword inside before the class, and the final fields no setter and deep copy. As you see here, that for the field we have to put the keyword final. The final keyword means that we cannot modify it. And the constructor we call this is the normal constructor, and getter the return the getter, right? As you see here that for uh, for this ones we create we using the deep copy. We perform the deep copy for this get copy method because the strings is a reference type inside the heap, right? Inside the heap we have another specific reason that holds like the string, right? And when we pass this string in back to the main, and in some way we can like modify the string, the list. We can modify the list, right? For example, like we add more element, or we right, because the list allow us to add element at the running time, like it helps us to achieve the uh, dynamic array. So in some way we can remove the or add element to task list, so but to achieve the immutable class we have to return the copy of this list, right? So that if we modify or add more element inside the list, it's going to work with the copy, so it's not affect the original list inside task class.